Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter classification of elements, that is the modern periodic table. So based upon the concepts which you have learned in the previous sessions, here we are going to see a practice sheet related to the chapter periodic table or classification of elements. Let us go through first the conceptual understanding questions. See the first one. According to law of triads, the atomic mass of the central element was nearly or merely. Yes, according to Dobrnier's law of triads, the set of three elements are called as triads. If these three elements are written in increasing order of their atomic weights, then the atomic weight of the central element will be equal to or merely equal to the arithmetic mean of the atomic mass of the first and third elements. Where it is? Here, the second one. Arithmetic mean of the atomic masses of the remaining two elements. For example, if you see, okay, we are going to see the next one. Select the following pair of elements in which their arithmetic mean of atomic weights is equal to the atomic weight of strontium. Yes, for the first one we can see example here. Strontium is one of the elements in the triads of Dobrnier from the set calcium, strontium and barium. So these three are when written in the atomic increasing order of their atomic weights. We get a series like this: calcium, sorry, calcium, strontium and barium. Now the atomic mass of the strontium will be equal to the average or the arithmetic mean of atomic masses of calcium and barium. Okay, according to law of triads of Dobrnier, the atomic mass of strontium will be equal to arithmetic mean of the atomic masses of the calcium and barium. Where it is? Here. Okay, next one. According to law of octaves, the properties of the elements are repeated with a difference of dash elements. With how many elements? 8 elements. So this set of 8 elements are called as octaves, and in the honor of the scientist who proposed these, they are called as Newland's octaves. That law is called Newland's law of octaves. Okay, 8 elements. Next, Mendeleev's periodic law is based on, yes, till the Mendeleev, all the scientists they have believed that elements are having in relation between the atomic mass and their properties. That is why they have tried to classify the elements based upon the atomic masses or atomic weights of the elements. So even Mendeleev also tried to classify elements on writing them in the increasing order of their atomic weight. So Mendeleev's periodic law is also based upon atomic weight of the elements. Next one. Total number of groups in the Mendeleev's periodic table. Yes, there are 7 groups in the Mendeleev's periodic table. Next, ecosilicon is now called. Yes, in the Mendeleev's periodic table, he left some places for the elements which are to be found later. And he named those elements also based upon the properties of the remaining elements in the same group. For example, a blank place is left down to silicon and it is expected to be with the similar properties to silicon. That's why he named that element as ecosilicon as he expected and left place. Later to him, scientists they have discovered that element and they named that element as germanium. So germanium was earlier called as ecosilicon before its discovery. Okay, in the same way, Eka boron was found as scandium and Eka aluminum is found as gallium. Now here Eka silicon is germanium. Newland could classify the elements only up to. Of course, he has given the classification into octaves, but it is limited for few elements only. This classification is only up to calcium it is suitable. Next one. According to modern periodic law, the properties of the elements are periodic functions of their atomic numbers. Till the Mendeleev, previous scientists they have believed the properties of the elements are periodic functions of their atomic weights that we will call as Mendeleev's periodic law. But in the modern periodic law, mostly considered instead of atomic weight, atomic number for classifying the elements. So it is given the law as the physical and chemical properties of the elements are periodic functions of their atomic numbers. Okay, atomic numbers. Next one. Lanthanoids and actinoids are together called as. Yes, lanthanoids and actinoids are present at the bottom of the modern periodic table. Those elements are together called as rare earth elements or inner transition elements, are also called F block elements. So here inner transition elements and rare earth elements is correct answer. So it will be now 2 and 3 is right. Okay. Next one. Beryllium belongs to which block? So how can we say by knowing the element to which block it belongs? Simply by writing the electronic configuration of that element, we can identify to which block that element belongs in the modern periodic table. We know the atomic number of beryllium as 4, isn't it? If you write electronic configuration for this beryllium with atomic number 4, we get it as 1s2, 2s2. Now after writing the electron configuration, if we observe the last electron, which we call as differentiating electron for that element, that is outermost electron, the subshell in which the differentiating electron or outermost electron present gives its block. For this beryllium, if you observe the last electron is present in S subshell. So this beryllium belongs to S block of the modern periodic table. In this way, not only beryllium, for all the elements in the same way, we can identify the block to which it belongs. That is just based upon the subshell in which the differentiating electron is located. Okay, next one. The 3D transition series contains elements having atomic numbers ranging from 3D transition series means the transition elements that are D block elements, third B group to second B, the middle 10 columns elements which are present in between S block and P block are called transition elements or D block elements. Out of these, the first horizontal row is present in fourth period, that is from scandium to zinc, 21st element to 30th element. They contain their outermost electron or differentiating electron in their 3D subshell. That's why these are also called 3D transition series elements. Okay, 3D transition series contains elements from scandium to zinc, that is element from atomic number 21 to the element atomic number with 30. Okay, that is called third 3D transition series, and the next period contains 4D transition series. Okay, in that way. Next one, elements of 1B and 2B are called. So these also come under D block elements or transition elements. 1B and 2B, which we can say as 11th and 12th columns in the modern periodic table. These two are called transition elements along with the remaining 8 columns. Okay, transition elements. Next one. Now let us see here about a single correct answer type questions. Which of the following is not a Dauberner's triad? Say chlorine, bromine, iodine is a Dauberner's triad. Calcium, strontium, barium is also triad. Lithium, sodium, potassium is also Dauberner's triad, but it is not given by Dauberner. Sodium, potassium, rubidium is not a Dauberner's triad. Next, in Newland's law of octaves, the eighth element after sodium. Just now I have seen here the third example if you see. lithium, sodium, potassium is one of the Dovernier's triad set. In this, okay, this is about Dovernier's triad. Here they're asking about law of octaves. Okay, sorry. In the Newland's law of octaves, the eighth element after sodium. So Newland also written the elements in the increasing order of their atomic weights, all the known elements. Then he observed the properties of an element in that series are exactly resembling with the properties of the consecutive eighth element. So for sodium, the consecutive eighth element in that order will be potassium. So sodium and potassium are having similar chemical properties. So for sodium, the consecutive eighth element is potassium. Sodium is a consecutive eighth element for lithium. Okay, now here, next question. Number of elements present in the fifth period of the periodic table is, we know first period contains only two elements. Second and third period contains each eight elements. Then fourth and fifth periods they have 18 elements in each. Then sixth and seventh periods they contain 32 elements in each. Now they are asking about the fifth period. So fourth and fifth periods both they contain 18 elements in each. Now fifth also will be having 18 elements. Okay, that's why you say these fourth and fifth periods are long periods. Next, which of the following pair has both members from same group of periodic table? Say which two elements belongs to same group? If you observe magnesium and barium, we know magnesium belongs to second A group. In second A, along with magnesium, the remaining elements are beryllium, magnesium, calcium, strontium, barium, and radium. So this barium also belongs to second A group. These two elements belongs to same group. Now that will be the correct answer. If you observe the next two, magnesium belongs to second group, sodium belongs to first A group elements. So it is not correct. If you say magnesium and copper, magnesium belongs to second group, whereas copper is a first B group element. So not belonging to same group. Even magnesium and chlorine also. Magnesium second A group element, whereas chlorine is seventh A group element. So only correct answer is magnesium and barium. Okay. Next, the liquid non-metal is, we know out of all the available elements, out of 118 elements, only two elements are existing in the liquid state at normal temperature. What are those two? Mercury and bromine. But here they're asking specially about liquid non-metal. We know mercury is a liquid metal, whereas bromine is a liquid non-metal. Bromine is the correct answer here. Next, the long form periodic table has, yes, how many horizontal rows are there and how many vertical columns are there in the modern periodic table? Yes, there are 7 horizontal rows which are called as periods, and there are 18 vertical columns which are considered as groups. Where it is here in the second one. Next one. Which of the following represents the general electronic configuration of D block elements? D block elements electronic configuration will be ns122 n-1d 1 to 10, because for these elements last shell, yes, S subshell, and last but one shell, that is penultimate shell D subshell are being filled. So for them the electronic configuration will be ns122 n-1d 1 to 10. Here it is, here second one. Okay, next question. Which of the following electronic configurations corresponds to an inert gas? See which configuration representing an inert gas configuration. Observe here. That should contain 8 electrons in outermost shell. If you observe, here it is 2s2 2p6. Totally there are 8 electrons in its valence shell. So here it comes under inert gas element. It is an inert gas element. What it is actually? It is neon. In the long form of periodic table, almost all non-metals are placed in. Yes, we know in the long form of the periodic table, if you see the generalized structure like this, isn't it? It will be like this. In this, almost all the non-metals are at the right side of the periodic table, that we say as P block, except only one element which is at the starting of the periodic table, that is hydrogen. So except hydrogen, remaining all elements are present in the extreme right side of the periodic table. That right side is called D block. So modern periodic table contains almost all non-metals in the P block itself. Okay, that's correct. Next one, D block elements in the long form periodic table are placed. So where these D block elements are present? D block elements are present in between S block and P block. That is the middle portion. At the middle of the periodic table, these D block elements are there. So in the middle. Next one. Which of the following is not a representative element? Representative element means the elements which belongs to S block and P block. Except noble gases, the remaining elements of S block and P block together called as representative elements. So here if you observe, except chromium, remaining all elements are either S block or P block elements. If you see sodium, calcium are S block elements. Boron is a P block element. So these three elements will come under representative elements except chromium because it is a D block element. Okay. Next, which of the following elements are known as typical elements? Which are called typical elements? The elements which belongs to third period are called as typical elements. Third period elements gives the generalized properties of that particular group. That is why these third period elements are called specially typical elements. Next, which of the following statement is correct about iron? What about iron? Is it an F block element? No. Does it belong to transition series? Yes, first transition series. We told earlier 3D transition series. In the D block, the first horizontal row is known as first transition series. Those elements are from scandium to zinc. In between these, there is iron. So iron belongs to first transition series. It belongs to fourth period, not third period. It belongs to eighth period, not seventh. So eighth group, not seventh. Okay, only correct answer is it belongs to first transition series. Next one. The elements whose outer electronic configuration vary from Ns to Np1 to Ns to Np6. If you observe in these generalized configurations, last or valence electron is being present in p subshell. The elements for which the differentiating electron present in the p subshell are known as P block elements. So these all elements will come under P block elements. Next one. Which of the following elements belong to S block of the periodic table? S block means extreme right side two columns. We know first column of this periodic table is considered as alkali metals, 1A group. In the same way, second A group elements are known as alkaline earth metals. These alkali metals and alkaline earth metals together called as S block elements because for these the differentiating electron is present in S subshell. Out of these two here they have given alkaline earth metals. So these are called S block elements. Next, identify the element in which the differentiating electron enters into S orbital but it is placed in the P block. This we can say one of the controversial points in the modern periodic table because all the S block elements are at the extreme left side. All the P block elements are at the extreme right side. But one element which has only S electrons, but it is placed along with the other elements in the P block. That is helium. If you write the configuration of helium, what do we get? We get it as 1s2. Means it has its differentiating electron in S of shell. It should be at the left side of the periodic table. But because of its stable electronic configuration and no idealness, it is placed along with the remaining noble gases in the P block extreme right side column. That is the 8A group. This we can say exception. It is a S block element kept in the P block. Okay, next one. Sodium is a strongly electropositive element. Yes, it belongs to first group. It is one of the strong electropositive elements. That's correct. Next was second statement. Chlorine is a strongly electronegative element. Of course, it is also correct. It belongs to 7th A group. That is all halogen group. Halogen group elements are strong electronegative elements. So both are correct statements, but there is no explanation between these two. What will be the correct answer? Both are true, but it is not the explanation for the first one. Right? Next question. The number of elements in second and third period is equal, isn't it? Yes. So first period contains only 2 elements. Second and third periods contain 8 elements in each. So second and third periods are having same number of elements. It is correct statement. And fourth and fifth periods they contain 18 elements in each. Those also have equal number. So both are correct statements and it is not the correct explanation of first one. Why it is so? Right? Second option will be correct now. See the next question. P block elements from form ionic as well as covalent bonds. Yes, P block elements can form both ionic as well as covalent bonds, covalent compounds. Second statement, P block elements, most of them are non-metals. Yes, because of that only, as non mostly they present non-metals, they can form both ionic as well as covalent bonds. For example, if you say chlorine, chlorine can form ionic bond with the metals. At the same time, it can form covalent bonds with the non-metals. So as these are present at the extreme right side, mostly non-metals, they can form both covalent as well as ionic bonds. So both the statements are correct and it is explaining the first one. So first option is correct. Next one. Now we are going to say about multi-correct answer type questions. See, identify the coinage elements. What are coinage elements? The elements present in the first B group or 11th group of the modern periodic table were used for making of these coins. That's why they are called as coinage metals. They are copper, silver, gold. They are called coinage metals. Okay. Next one. Mendeleev's periodic table. In the Mendeleev's periodic table, the triad of 8th A group. So in the Mendeleev's periodic table, there are three sets or three triads in the 8th group. They are iron, cobalt, nickel, ruthenium, rhodium and palladium, osmium, iridium and platinum. These three sets come under triads of Mendeleev's periodic table from the 8th group. Next, which of the following represent or representative elements? So yes, we told representative elements means the elements which belongs to S and P blocks together considered as representative elements except noble gases. Now if you observe here, iron is a D block element. Potassium is an S block element, even calcium is also S block element. Nitrogen is a P block element. Now, these three elements, potassium, calcium and nitrogen are called as representative elements, whereas iron is a transition element. Okay. Next, which of the following statements are correct about modern periodic table. See, some statements are given about modern periodic table. Let us find which are correct about it. It has 7 periods. Yes, of course. Modern periodic table has 7 horizontal rows which are called as periods. It is classified into 4 blocks. Yes, modern periodic table is totally classified into 4 blocks. They are S, P, D and F blocks. It is done based on the atomic numbers of the elements. Yes, it is also correct. Modern periodic table is constructed based upon the atomic numbers and electronic configurations of the elements. Fourth point, you say noble gases are cited at extreme left side of this periodic table. Is it true? No, because noble gases are present in the extreme right side of the modern periodic table. That is in the 18th column or 8th A group, which is also called zero group. So they're at extreme right side, but not at the left side. So this is incorrect statement about that. Remaining three are correct statements. Next one, which of the following is correct for D block elements? See, what about D block elements? These elements are situated at the extreme right side of the periodic table. No, because they are at the middle, not at the right side. General electron configuration of these elements is ns2 np126. No, it is p block elements general electron configuration. For them, the general electron configuration is ns122 n-1 d 1 to 10 is their general electronic configuration. So it is also incorrect statement. They show variable oxidation states. Yes, it is correct. They can exhibit more than one valency or oxidation state because they have incompleteness in the two shells. And next one, these block elements form alloys. Yes, these elements can form alloys. They can be mixed one into another. So the correct statements about D block elements are these two. Next, now let us see comprehension paragraph. Number of period in which the given element is present is equal to the valency shell number of that element. Yes, the number of shells present in a element gives its period number. Number of elements present in third period. How many elements are there in third period? We told first period contains 2 elements, second and third contains 8 elements in each. Next one, longest period in the modern periodic table. Yes, first period has only 2 elements, second and third have 8 elements in each, so they are called short periods. First one is called very short or shortest period. Fourth and fifth have 18 elements in each, so they are called long periods. Then sixth period and seventh periods, they contain 32 elements in each, so they are called longest periods or very long periods. But earlier the seventh period is being incomplete, but in the latest scientists, they have discovered those elements also and filled this seventh period also completely. So now we can say sixth and seventh periods both are longest periods. Next, the subshell filled in fifth period. If we take fifth period, there are around 18 elements. Yes, for S block elements, fifth 5S subshell is being filled. And for P block elements, 5P subshell is being filled. And for D block elements of fifth period, penultimate shell D subshell, that is a fourth shell D subshell, 4D will be being filled. Now, all of these are being filled in the fifth period. Next, let us see one more paragraph. Classification under the necessity for the classification of elements is given here. You can read once these points. It helps in understanding the properties of the elements in the good manner. So it makes a remembrance of the properties of the elements in the easy way. Okay. Now let us see questions based upon this. The elements which are malleable, ductile, and good conductors of heat and electricity are generally classified as. What are those? Metals. The elements which are malleable, ductile, good conductors, and electricity are called as metals. The elements which are Non-malleable, non-ductile, bad conductors of electricity are named as non-metals. Okay, next one. The elements possess both metallic and non-metallic characters are named as. Yes, the some elements are present in the elements which can possess the properties of both metals as well as non-metals. Such elements are called as metalloids. Okay, example silicon, germanium, like these elements, they can possess the properties of both metals and as well as non-metals. Hence they are called metalloids. Next, let us see here matrix matching type questions. Say some groups are mentioned in the column 1 and their common names or generalized names or special names are mentioned in column 2. Try to match these here. 1A group elements. What are they called? 1A group elements. They are called alkali metals, isn't it? Second A group elements, they are called alkaline earth metals. Seventh A group elements are called halogens. Meaning of halogens is salt formers. Eighth A group elements are called noble gases or rare gases or aerogens. Now try to match these properly. Check this once. First group elements alkali metals, second group alkaline earth metals, seventh A group halogens, eighth A group rare gases or noble gases. Okay, this is about matching. Okay, this is a practice sheet related to periodic table. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos.